Hello everyone, good morning, good afternoon and good evening. My name is Vishvadeep and I welcome you all on PW platform for operating systems number 2, lecture number 2. We are going to discuss process management today. But what is process? We don't know about it. I mean, you don't know about it. If you don't know process, how you will know that what we are actually trying to manage? It's okay. No worries, no problem. In this class, we will talk about process, how the process actually behaves, and its small concepts. Before we start, I want you guys to have the comments in the comment box. Are you guys ready? If yes, then let's get started. What is a process? See, we write the programs, yes, and we want to execute them, yes. So as soon as you want to execute the program, that program becomes process. What change has happened? I wanted to run the program, yes, it's a program itself, right? The running program is called as a process. So there is a definition over here. The definition is program under execution is process. What is changed, my dear? What is changed? What makes a program a process when it goes for execution? So what happens? The process is nothing but the program, but along with program, some runtime activities are added. And what is that? I'll give you a very simple example for that. I have an aeroplane. Yes, this aeroplane I do have. Okay, this is an aeroplane. Aeroplane is called aeroplane. Yes, this is my program. It's an aeroplane. But when I run this aeroplane for a specific, destination, then that becomes a flight. Difference? Two words, not. Aeroplane is aeroplane, a particular vehicle. Yes, it can fly. A vehicle which can fly. But when I talk about flight, then a lot of informations. Then this particular aeroplane will fly from Bangalore to Hyderabad. Okay, on date 27th of June. Which time? 8 a.m. in the morning departure from Bangalore and 9:12 or 9:15 a.m. in the morning arrival on Hyderabad airport. How many seats are there, who will fly it, and lot of other information. What will be the charge for one particular seat in this particular aeroplane or this particular flight? All these information, if you attach with this aeroplane, the aeroplane becomes a flight. Aeroplane, a quantity, a particular vehicle, a program. But when you try to run it, let's say I am flying that particular aeroplane, then it becomes a flight. And what is the difference? It becomes a process. Are you understanding the point? So when program runs, then it becomes a process. But what are the runtime activities, sir? Runtime activities means the data stack of that particular program and many other things which are included in the program to make that program as a process. In some time it will be cleared, but basic idea is clear. What is a process? So program, if it goes for execution, it becomes a process. So whenever we say multi-programming operating system, yesterday we have discussed, na? Yesterday we have discussed it, na? Multi-programming operating system. Yes or no? In multi-programming operating system, what did I tell you? In the main memory RAM, we will be having multiple programs residing. Those programs are not actually program. Those are processes. Yes, these are processes. So in the main memory, apart from operating system, whenever you say I am running program P1, which means that program P1 should be there in RAM. Yes, now that program is no more only the program, it becomes process. Yes, exactly, you are understanding it correctly, it becomes process. So in main memory, whenever we say there are programs, those are not actually programs, those are processes. Is that clear? Is that clear? If yes, then let me explain you the next thing which will help you understanding the process even more. See, I'll tell you guys one thing. Learning any course, especially operating system or computer organization architecture, such kind of courses, when you start learning, DBMS also same. So many courses are having this kind of thing, that learning a particular course is something like watching a thriller movie. In thriller movie, what happens in the very first half, or in few minutes, or in first 10-15 minutes, do you understand what is gonna happen next? No. There are a lot of suspenses, yes, but what you do, you have interest in watching the movie, yes, you keep watching it, so that when the next scene comes, then next scene comes, and next scene comes, slowly all the suspenses will be uncovered, and whatever they have shown in the starting of the movie, that will be shown at the end of the movie with more clarity, that oh yes, this has happened at that time, that is why this particular new event is what connected to that event. So that connection between the events, scene, story happens only in the later part of the movie. Exactly same thing here. Exactly same thing here when you learn a particular course. Initially, you do not get every single thing, but these are the suspense. Yes, you need to remember these. Every story, small part, you need to remember, so that later on the related concepts will be unfolded. You will have a better clarity of the movie. I hope you understand that, right? Let's go ahead. So, representation of a process in the main memory. In main memory, what does it say? It says that in the main memory, every process is stored in 4 parts. So let's say in main memory, apart from operating system, so many processes are there. In main memory, operating system is there, yes. Process P1 is there, process P2 is there, process P3 is there, process P4 is there. So many processes are there. Multiprogramming OS, multiple processes are there in main memory, yes. Each process you are storing should be stored in 4 sections. How many? 4 sections. If I am talking about P1 process, yes, my dear friend, P1 process will have 4 different sections. Why? To store 4 different things. See, in house also you have such kind of arrangement. Yes, some particular cupboards or almiras are having such kind of arrangement, that here your mom will keep her saris, here your dad's shirts, pants and other dresses are kept, here in a small section your 2-3 dresses are kept. Like this, each part is used for a separate special purpose. Same here, when main memory is storing the process, yes, in that particular process, each process is stored in 4 different sections. Each section will be used to store the different kind of content for the process. What these are? What these are? The first thing is code or text section. Second section called as data section. Third section called as heap, and fourth section called as stack. The students who have studied programming language will be connecting to me in just few seconds itself, as soon as I will explain which all content will be stored in these 4 sections. Immediately you will connect, immediately, in a flash of a second. Yes, we heard this. So code section, text section is your program actually. You have written the program. Yes, program has lot of instructions. Yes, this is what your program. Then these 3 part are the part of your runtime activity. Yes, that's why collectively it becomes process. So program instructions will be here. Program instructions will be stored in this code section of the process. Then data section. Data section will be used to store the global variables and static variables. I told you guys in just 2 minutes back, I told you the student who have studied programming language will know about it. Have you heard about global variables? Have you heard about static variables? If yes, then these 2 things are kept in this data section. So global and static variables are kept into this particular data section. So when you write a program, when you define any global variable or a static variable, then those variables will find space in the memory here. Are you guys able to remember programming? You studied programming, na? No. You must know. You are a computer science student. You must know the programming. This very basic. I am expecting that at least this much though you should know. If yes, then at least comment. Next thing is stack. Stack is used for what? Local variables. If you have some function parameters, then that too stored here. Function parameters. And what? And what? Return addresses and many other things. This return address concept you will understand in COA. Local variables, function parameters, we know from the programming. So when we call a particular function, in the function, in the body, if you have defined some parameters here, where these function parameters will get the space? In the stack only. In the function, if you have some local variables, those also will be in the stack only. This heap will be used for dynamic memory allocation. Using malloc and calloc functions, however you call it as malloc, calloc, such kind of functions are there. If you are using such functions to, create some variables or pointer or whatever on runtime, those are runtime memory need. When you run the program, at that time you need, okay, I need 2 byte more space or 4 byte more space. Where it should be given as? In this heap it will be given as during the runtime. Will this be full course or not? If I say this will be full course, but you will be available in the class daily for the full course or not? That is also a question. If you want a commitment from your end, from my end, then I will also want a commitment from your end. To run this particular class till the last day, I want commitments from you guys also. That if I will have to come daily here, you will also have to come daily here, na? If you will not come, then for whom I will teach? So if you guys are ready, I am also ready to teach full course here. Dynamic memory allocation will be done in heap. Now, when a process is created, this much of space will be given to process always? Yes, always. Now what? Look at this. Program instruction, fixed size. Just because after writing the program and creating the process, its size will not change. Similarly, data section also size is fixed. Once program created, process created, data section will be fixed size. But stack and heap size may vary during the program execution. When process will execute, then if during execution you need extra space through dynamic memory allocation, then that extra space will be given from here. If you delete the extra space, removed from here. So the size of heap can increase and decrease. That's why some empty space is already given here. So that empty space heap can use. Similarly, during the runtime, stack size also can increase and decrease. That's why some empty space is given between heap and stack here. Understood? Got it? Got it? Now, I do have a question. When a process is created and that particular process comes into the main memory here, the process itself gives the space in main memory to itself, or somebody else allocates the space to process. Space means from which address to which address this particular process P1 will be stored in main memory. Who will allocate this space to process P1 when it comes to main memory? Who will do that? This OS. See, we say that CPU is the master of computer system, etc., etc. Yes, CPU makes other hardware works. But CPU also works as per the operating system. So real gangster of the computer system is OS. OS is real gangster of entire computer system, just because OS is actually controlling everything. So if let's say currently here I am, look at this. I am not using Chrome. This is a Chrome. Yes, it's a program. It's a program currently. I am not using it. But if I want to use it, I double click it. Now this particular Chrome started running. This Chrome started running. Yes, before it was not running. Later it started running. Before, when it was not running, then the Chrome process was not there in RAM. When I double clicked it, this operating system has brought my Chrome process into RAM. From where? From your secondary memory. You might be having internal storage in your computer, whatever you call it as hard disk or SSD drive. You have it, right? You have it, na? SSD of 256 GB or 512 GB or 1 TB or something. You have, na? So your Chrome is installed over there, but as soon as you double click on it, that particular Chrome will be brought into main memory. Who will bring it? This gangster will bring it. This Chrome software, which we now call it as a process. In terms of operating system, this is a process. So where in the RAM, on where it will be stored, who will decide? This gangster operating system will decide. Operating system will decide that this particular program or the process will come where in the main memory. OS will make these 4 sections for it, will store the process, and then after that OS only will schedule the process to run. Okay, Chrome, you run on CPU now. When Chrome starts running, then you see its first page. It takes time, of course takes time, but you don't understand that time just because it's a very fast process. Look at this. I am double clicking on this. After double click, a little time you can feel. Yes, before opening. This is what the time taken for this entire work I have explained. You can feel it by your own eyes. You can feel it. You can sense it. Just because it is a delay but lesser than 1 second. You can feel it. I'm not from CSIT, from EC, but I learned COA from you. Thank you so much. Thank you so much. One more thing you can do is just keep learning. so that you can have a great career ahead. And if you have friends who wants to learn COA, let them know about the classes. Okay, so this 4 sections who will create for the process? OS will create, so that when process wants to run, process can run. Use these 4 sections. Now can you please confirm me, you guys understood that these are the 3 part which are what runtime activity. This is the program plus a runtime activity called as process. Called as what? Process. Understood, right? Yes. When you understand the real logic behind whatever we are learning, then you can remember the concepts also. And that's why that example of opening the Chrome I have explained. Now, next is what? Operating system has created process in main memory. Yes. These processes will run on CPU one by one. Yes. But OS wants to control them. Them means to these processes. Operating system wants to control these processes. Why? Just because real gangster is operating system. Real gangster of computer system is OS. Even though there are hardwares like CPU and other hardwares, fine. Even though there are so many processes, fine. But everything is controlled by this gangster, Godfather operating system. So if operating system wants to control them, how? OS should know about these processes. That which process? What is the name of this process? What is the name of this? What is the name of this? What is the name of this? Where this process is stored in the memory? How much space it has taken? What is the size of process? Do we have the priority of the process? Which process is high priority? Which one is low priority process? What is the type of process? What exactly this process wants to do? Every single thing about the process, whatever needed, should be stored with OS, should be there with OS to control OS. Like you guys, you take admission in BTech, already taken. Some graduation you are doing, right? BTech or whatever graduation you are doing na? Graduation you are doing na? You have taken admission in some college. Yes. If you are in some college people have some information about you. They have some information about you. What is your name? What is your address? Current address, communication address, then your father's name, your 10th, 12th, where you studied 10th and 12th, how much percentage did you get, and your mark sheet, etc., etc. College, when did you pay the fees? When did you take the books from the library? And every information they have it. Why? Just to control your activities. If you haven't paid the fee, there will be a notice in the class. This fellow has not paid the fee. Pay it before this particular date. Otherwise, your classroom will be not allowed. You will not be allowed in the class. So they want to control it. Yes, that's why they are keeping your information. Same here. Processes should be controlled by operating system, and that is why OS keeps your information. Your means this process ka information. So for each process, a particular box is maintained, and that particular block is or box is called as PCB. What it is called as? PCB, process control block. That dabba, that box is called as process control block. Okay, so what happens? There is a PCB, or known as a process descriptor also. What it does? Stores the attributes of process. Now, very important point. Operating system maintains separate Should write it 2 times. PCBs for each process. For each and every individual process, a separate PCB should be there. So look at this. The scenario is something like this. You have operating system, and then you have so many processes. Process P1, then process P2, then process P3, and so on. Process P1, 4 sections. Code section, data section, heap, stack. P2 has its own 4 sections, its own stack, its own heap, its own data section, its own code section. P3 also 4 sections. These are the real processes. To control these processes, OS has their control points called as PCBs. So inside OS, we have PCB of process P1, this one, then PCB of P2, this one, then PCB of P3, this one, and so on. For all the processes under OS, PCB of each process is there. Getting it? Getting it or not? Are you getting it or not? Now look at this. Look at this. What all there in that particular PCB? The first thing is process ID. Very important. Why? Each process, when comes to main memory, OS gives it an ID, a unique ID, so that each process can be identified. OS wants to identify each and every process uniquely. That's why OS assigns a unique ID to each process. Then some registers, program counter and general purpose register. What is that? I will explain you later. This is program counter. This is general purpose register. The student who knows COA will be able to connect them. If not, then it's okay. When you will study COA, you will understand them. I'll explain the logic behind it. Sure. List of devices. What does it mean? This process, let's say P1 process. If P1 process is running, then that process is using which all devices? Is it using camera? Is it using microphone? What all devices operating system has given to this process for usage? That is list of devices. Second thing, type. What is the type of process? Is that a foreground process? What is the meaning of foreground process? The foreground process means the process which is visible on the screen to user. Like this, Chrome is foreground process. This note, this is foreground process just because user is getting some kind of interaction with this process. User has some screen thing for that process. There are so many background processes which are running in background, but user is not having any view of that. There is no any display of that. I'll explain you. Yesterday also I have explained it. I will explain you. You can check all these background processes here in Task Manager. Go to the Task Manager. These are background processes. Some anti-malware service, Unicode, AnyDesk, COM, device association framework. All these processes are there in RAM. Yes. But can I see that on the screen? No. I can open it and work on it? No. Then it is needed for computer system. That's why these processes are here. Understood? These are background processes. So what is the type of this process? For each and every process, what is the type? OS maintains it. Size in the main memory. How much size it is taking in main memory? 1 MB, 2 MB, 5 MB, 15 MB. That size. Memory limits. Memory limits means in memory from which location to which location P2 is stored. That is the limit. Then priority. Every process has a priority number 1, 2, 3, 4, 5. So which process having which priority? That some processes are very high priority processes. So their priority number will be better than others. Then state. Currently process is doing what? Is it running on CPU, or it is waiting for CPU, or it is using IO device? What exactly the process is doing? It's a state. The state thing we will discuss in the next lecture. What are the different process states we have? Then list of files. Did I open any file in the process? If yes, then all the name of the files will be mentioned here. Like. Without example, to you don't understand. Look at this. This is the process PowerPoint. This is just the process, my friend. PowerPoint is the process. Opened? Yes. But in this PowerPoint process, I did not open any file now. So list of files open in the PowerPoint, nothing. But as soon as I try to open a file, let's say this one. I guess, yes, got it. This particular file I have opened. When this particular file I have opened, which was having a name L2 OS process management, then what has happened in this case? This particular file opened, yes. Now list of file opened in the process PowerPoint is this one. If I want to open another file, I can go ahead. Yes, open another file. I'll open two files I can open in PowerPoint. So how many processes you have opened in the PowerPoint, those all file, their location, their name, everything will be mentioned in that list of file for that attribute here, so that OS will have a control. OS will know that this particular program has opened what files. All, yes, all, every list they have. Fine, sir. These are the things understandable directly. This is the thing understandable directly. What is this? Register values and all. Yesterday I explained you multi-programming system, and in that multi-programming system there was an extension called as multitasking system. In the multitasking system, each process run in the round robin manner. Now in the round robin manner, let's say one particular process runs for 2 nanosecond time. If you have already executed a process for 2 nanosecond time, just imagine here, you have run P1 process here for 2 nanosecond, and after some time you again run P1 process for some time. Can you tell me, if I stop P1 process here and again after some time I run P1, then will I resume P1 process or will I restart P1 process? If P1 process stopped executing in CPU for some time, after some time, and then later on again if P1 is coming back for execution here after some time, in between that some other processes are also running in CPU. So if P1 again comes back in CPU, then here P1 you will resume from the last point or P1 you will restart. Tell me. And I am hoping and expecting that these two words are clear in your mind. Restart and resume. Restart, फिर से शुरुआत से again से start करेंगे. Resume means from wherever you left, ahead of that we will execute. जहां आपने पिछले छोड़ा था उसके आगे execute करेंगे. I am explaining it Hindi so that the people who are from different background, not from Hindi medium, English medium, they can understand that. Okay, so you are saying resume. Of course, if already I have put some efforts to run a process, then I will run it ahead only, na? Then again ahead, then ahead and ahead and ahead. Yes. So if that is the case, then once you were running P1 process inside CPU, yes. After some time, if you are taking CPU or taking P1 process out of the CPU, if you are taking P1 process out of the CPU and you are running some other processes, how do you know that how much you have already run the process P1. How will you know that this much I have run the P1 process and this is the current status of the P1 process? How do you know that? You need to store it somewhere. You need to save it somewhere. It's exactly same. Let's say you will have to type a big file for your final presentation of some thesis, some kind of project work. One day is not sufficient to write entire file. So you started working on the file. You have written and edited some 4-5 pages. After that, if you will again work on that file tomorrow, then how will you know that yesterday how much work I have done? You will save the file. What you will do? You will save the file in somewhere in the disk or pen drive or somewhere, so that you can open it again when you want to rework on that. So that after 4-5 pages, further you can write ahead. You will not have to write from scratch just because you have saved your work. Exactly same thing happens in computer system. What happens? Exactly same thing happens. And what I am going to explain is the masterpiece of computer system work. Masterpiece knowledge, I am saying. Masterpiece knowledge of computer system, and you won't get this particular knowledge anywhere. So listen and remember this, just because this is very, very exclusive content which I am bringing only for you guys. And that's why I'm telling you, I will be faithful to this course if you guys will be faithful to the live classes. If you come over here, give me the responses, have active participations, I will love it. I am a teacher and I teach. I need from you, your end is interaction. Otherwise, I will not enjoy teaching. My, my enjoyment of the teaching or satisfaction of the teaching is purely based on how active and interactive you guys are in the class. So whenever I keep asking, keep talking in the class, so that I will be having an idea you guys are listening and learning. If I feel like you guys are just not coming or not enjoying just because you are not commenting, I'll not be able to continue this. Okay, let me come back here. So the people who have studied COA ever before, they might be knowing this. The students who did not know it, it's okay. I will give you some kind of idea. To execute the processes, CPU has some small memories called as registers to keep the running process content. Whichever process is running, its content, program counter is there, some general purpose registers are there, some other registers like address register and accumulator, and so many registers are there. Registers in CPU to execute process. Let's say P1 process is running in CPU. If P1 process is running in the CPU, then what happens? The program counter value, all the general purpose register values, address register will hold some value, accumulator also will hold some value. These are small registers where you put some values about the current running process. If P1 is running, regarding P1 process, all these values will be there in the CPU's register, so that P1 process can run. Fine. Now, my requirement is, I want to stop P1 process. I want to stop P1 process. Boss, P1 process is not completing, huh? It is not executing fully. It is just stopping for some time in CPU. It is leaving the CPU temporarily. After some time, again it will come back. So you'll say, why CPU? It is leaving the CPU. Why P1 is leaving the CPU? So that other process P2 can run in CPU. I do have only one CPU, and that CPU can run only one process at a time. So if I want to run P2 next, my choice, my requirement, hard, fast requirement. Oh my God, it's an urgent thing to run P2. I'll have to take out P1 and then I will run P2. If I am taking P1 out of the CPU, it is not completed. Then after some time, if I want again P1 to run, I do not want restart of P1. I want P1 to resume. But if I want P1 to resume, whatever the progress P1 process had in execution, I will have to save it somewhere. Yes. Are you guys getting what am I asking? What am I explaining? तुमको समझता है क्या जो मैं समझा रहा है? Are you guys getting it or not? What am I explaining? Are you guys getting it? So what I am explaining, P1 process I'll have to stop in between. And I want to run next P2 process in CPU. If I want to run P2 process in CPU, then I will bring program counter value according to P2. General purpose register values according to P2. Address register according to P2, accumulator according to P2. All these values I will bring according to P2 so that P2 can run. Fine. But these registers are currently holding the values according to P1. If I will bring some other values on the top of them, then P1 ka value will be lost. Nakkore baba, I can't lose that. No, I do not want to lose those values. So what I will do, not I actually, this operating system will do. What operating system will do, whatever current process which I want to stop, it's all these register values operating system will bring out and will store these values inside PCB of P1. So OS is having the control over process PCB. Yes, in the PCB, for all these values, we have some sections. This program counter, general purpose register, and all other register ka space we have. So what we will do, whatever values are there, program counter value is there inside it. Okay, you copy it here. General purpose registers values are there, copy it here. Address register values here, accumulator here. All these register values are taken out for P1 process and kept into its P1 process ka PCB in the main memory. Why I am saving those values? So that later on, if I will want P1 process to run again, then all these values I will put back into registers so that my CPU will run P1 process from where we left. It will resume P1 process. That's why I am saving these values into PCB. Fine, sir. You have saved these values from here and copied these values in the P1 ka PCB. Fine. Now next what? Next you want to run P2. How my CPU will run P2? CPU will need these values according to P2 process. Yes. So operating system will say thamba CPU thamba, stop, I will give you. चिंता नको करो, टेंशन नहीं होने का. No tension, I will give you money. No. I will not give you money. I will give you these values. So what happens if next process P2 will go for execution? PCB of P2 has these all register values. Yes. Stored in its PCB. Yes. So these values will be loaded from this saved PCB to registers. So what OS will do? OS will bring all those register values from CPU and save them into process P1's PCB, so that later on if I need, I can resume P1's values or P1 execution through these values. And if P2 should run next, all these register values taken out of P2 and loaded into registers. Loaded into registers, so that CPU will execute P2 as per the loaded values. So what exactly we are doing? We are switching the values. These PCB values we are switching between the CPU or between the two processes. That is why this switch is called as context switch. Context means what? These values. These values of PCB collectively called as context. I am taking out context of P1 from CPU, saving it into PCB, and I am taking context of P2 process from PCB, from main memory, and loading them into register so that P2 can run. So ultimately, when you will learn operating system, sorry, the wrong word. If you study operating system, no learn, study. For semesters, you only study that. Study, pass the exam and forget. You don't even remember what are the terms. Here we are not only for study, we are for learning. So when you study your operating system in college, what they teach, what is the meaning of context switch? Taking out one process from CPU and running other process to CPU. One process coming out of the CPU, other process goes into CPU. But process means what? This is the scenario. I told you this is a very exclusive content and you will not get anywhere. This explanation you will not get anywhere. So what is the context switch? Context switch means what? Register values of a current running process are saved into its PCB in main memory. So that PCB will be there in RAM under operating system's control, and register values of next process which I want to run are loaded into CPU from its PCB in main memory. Can you please confirm if these two statements are clear to you guys? Can you confirm if these two statements are clear to you guys? Please confirm. Can you please confirm these two statements are clear for you guys? Context, the content in the PCB, the register values of the process collectively known as the context. That's why context switch of the two processes. And who does this context switch? There is a special program of OS called as dispatcher. Dispatcher does context switch. This is a very important term. Remember that. Who will do the context switch between two processes? Who will do the context switch between two processes? dispatcher. There is a program of OS. That program of OS will do this context switching of the processes, called as dispatcher. Okay, in basic idea, if one process is running in CPU, that process will stop and next process will run. That is context switch. But to stop one process and to run next process, what all to be done, I have here explained it, and in the detailed manner I have explained it. And this PCB is under the control of operating system. Remember that. This PCB of each and every process, if let's say 15 processes are there in main memory, OS will have 15 different PCBs. So PCB will have those, OS will have those PCB of each and every process, so that OS can control each and every process from PCB. Okay, fine. Chalo. So today's lecture was this much only, just because we have the next upcoming concept called as process transition, process state transitions. There are different states of a process, what exactly process does based on that, and then process can have the transition from this state to that or that state to that, like that. So that particular transition and different states and their characteristic, tomorrow we will gonna discuss. Okay, so we will be discussing those things tomorrow. You guys will be having one of the most interesting classes tomorrow. How exactly those states are, practically we will understand. Okay, yes, I have seen this. If you have ever installed any application on your Windows phone, or sorry, Windows operating system in PCs, then you will be having idea. Oh yes, this has happened, sir, with me. Oh, yes, I have observed it. So when you use computer system, you might have gone with lot of experiences. Those experiences we will be uncovering tomorrow with more technical details of it. We will have so much of fun tomorrow. So please be here live and you will enjoy the class tomorrow. Thank you so much.